All right, so on this skill 2, it was solving equations. Now we had, let's look at some preliminary stuff because we had several different types of equations that we looked at. The one that you may be most familiar with is a quadratic equation because you studied it quite a bit in Algebra 1 and Algebra 2. And we continued that studying it in the college algebra. In standard form, we had ax squared plus bx plus c is equal to 0. Now, our first attempt is usually to try to factor this, but sometimes you can't factor this quadratic expression. And what will always work is to use the quadratic formula. So you must know the quadratic formula. And you also must know some information about the quadratic formula. The underneath the radical here, you've seen that I used a different color, the b squared minus 4ac. This part of the quadratic formula is referred to as the discriminant. And based upon that value you get when you calculate b squared minus 4ac, will determine what type of solution that you'll have for your equation. I think that'll make sense if you think about it. When you first learned it, you could not take the square root of negative numbers, so you very often would just, well, you did say no real solution. But now that we understand complex numbers, we know that we can take the square root of a negative value and get a complex number. Sometimes this b squared minus 4ac, maybe it's not negative, maybe it's just 0, and you're adding and subtracting 0. So the numerator is just negative b divided by 2a. Well, that's not plus or minus anything, that's just a single solution. So if you're taking the square root of 0, that's 0, and you have one solution. Well, what if this discriminant is positive? If it's positive, like the number 100, well, you would take the square root of 100 and say plus or minus 10. But what if it's a number like 99? When you go to take the square root of it, you really can't simplify it very much. We can look at the square root of 99 and say it's not a perfect square. The biggest perfect square that divides 99 is 9, and 9 times 11 is 99. So we can simplify this radical 99 to 3 times radical 11, but our final answer when we have this plus or minus is going to be some radical in our answer, and our final solutions are going to be what they refer to as irrational numbers. Rational numbers are the numbers like 5 or a number like 2/3, where you can write it as a ratio of integers. When you have this square root of 11, that's an irrational number. So we know that we have seen problems where it will say describe the nature of the solutions based upon the value of the discriminant. So let's break that down a little bit, and write down what I was just saying verbally. You have four possibilities. Like I say, this discriminant could be negative, or it could be 0, or it could be positive. And when it's positive, maybe it's a number like 100 that's a perfect square, or maybe it's a number like 99 that's not a perfect square. So when you're discriminant, when you're taking the square root, if this b squared minus 4ac, if you identify a, b, and c for your problem, maybe it's 1, 2, and 3. When you calculate this b squared minus 4ac, you'll get a number, and if that number is negative, if that number is less than 0, you know that your solutions to the equation are going to be imaginary. They're complex numbers. That b and a plus bi is not going to be 0. Now, if underneath this radical, if this number b squared minus 4ac is 0, then you're just going to have a single numerator. See, this negative b plus or minus represents two possibilities. One when you subtract, the other when you add. But if you're adding and subtracting 0, that's not changing that negative b, so you're only going to get one solution. And since we assume that the a, b, and c we're working with rational coefficients, we don't have irrational values for a, b, and c, nor do we have imaginary numbers for a, b, or c. So if b squared minus 4ac equals 0, you only have one solution, and that solution is a rational number. So you have one rational solution. Well, what if your discriminant is positive? That was the situation that I was talking about, if it's positive 100 or a positive 99. If it's positive, you have two possibilities. You might have a perfect square, like 4, or 36, or 49, or 100, or 144. When you take the square root of it, you get an integer value. It's a perfect square. But maybe you have a number it's positive, but it's not a perfect square. A number like 11, or 12, or 99, or 3. You know, when it's a perfect square, those two solutions are referred to as rational solutions. You won't have a radical in your answer. But when you can't simplify that radical, when it's not a perfect square, it's called an irrational number, and you'll have a radical in your answer. So we're going to see problems like this later, and we'll come back to this, and I'll point it out again with specific examples. But you should try to familiarize yourself with the idea and the 4 different possibilities that you could have for any kind of a quadratic equation. We also took a look at equations that were called rational equations. Again, rational is a ratio. Think fraction. We had a fraction where we had, I don't know, some numerator, but in the denominator we had a variable. And maybe we had more than one fraction that had variables in the denominator. And that could have equaled, again, a variable expression, or maybe even just a number. The technique that we used to solve these rational equations was to get a common denominator. Then once we had the common denominator, we canceled all of our denominators by multiplying that common denominator to every term. But in multiplying both sides of an equation by a variable, you introduce the possibility of extraneous solutions. Answers that check your immediate equation, but don't check the original equation. Our original equation, we have to be very careful of division by 0. So when we're looking for these extraneous solutions, we're typically looking for values that when you plug it in to check in your original answer, it caused division by 0, and that's not permitted. Division by 0 is undefined. A third type of equation that we looked at was radical equations, where you had some variable that was underneath the square root, or maybe you had more than one radicals that had variables there. Our technique was to get the square root by itself. The other side might have square roots, it might not, and we squared each side of the equation. If it had a radical when we squared it, we isolated that radical and squared it again. So sometimes these problems can be long. I don't really think that you had a lot of difficulty with them, other than because there was so many steps. With each step introduces the possibility of a sign error or a silly arithmetic error. Again, whenever you're multiplying both sides by a variable, or whenever you're squaring both sides of an equation, you might introduce extraneous solutions. We have to check our answers to make sure that we're not taking the square root of a negative value. Because when we're working with these radical equations, it's not like we looked at with the complex numbers. It's going to be too difficult for us to have answers that are complex numbers. We're not going to have x being plus or minus 3i like we did when we were looking at quadratic equations that could have complex numbers as answers. When you go to plug that in to check it and you're taking the square root of an imaginary number, that's a little bit beyond the scope of this class. You might learn it if you took some additional math classes like a pre-calculus or a calculus class. Alright, so let's take a look and see if some of these specific examples may help you prepare a little bit. I notice here on the left hand side that we have 3 terms, but I also notice that every term has something in common. They all have a factor of x. On the right hand side I have 0. I need my equation set equal to 0 if my technique is going to involve factoring. And that's exactly what I'm going to do. I notice that an x is common to every term. I'm going to factor out a common x. When I do that, I'm still going to have 3 terms here, but this first term is now going to be x squared. Because I factored out a single factor of x, And when you multiply these, you would add the exponents 1 plus 2 to get that 3 back if you were distributing this to check to see that if I factored it correctly. My middle term here, I'm going to factor out one of these x's and just have minus 5x remaining. Again, if you added the exponents, 1 plus 1 is 2. On this last term, if I factor out that x, I'll just have this constant, this minus 36. So here's something that you've seen very often in Algebra 1 and Algebra 2 and in this class, and that's the fact that we have a zero product theorem. If you have two numbers and they multiply together to give you 0, it has to be true that one or both of these numbers is 0. 5 times 5 is not 0, but 5 times 0 is, or 10 times 0. One of these numbers, or even 0 times 0, one or both of these numbers has to represent the number 0. So either x is equal to 0, or this quadratic equation, x squared minus 5x minus 36 equals 0, or both of them. Now that we have this quadratic equation, we can try to factor this, or we can use the quadratic formula. If you do use the quadratic formula, it will always work. Identify a as 1, b is negative 5, c is negative 36. But it looks to me like this one that we can factor this, and that might save us some time. So if we look for two numbers, when multiplied together give us negative 36, but add together to give us negative 5, through some trial and error on the side, or just through thinking about multiplication and factors of 36, I hope that you come up with a negative 9 and a positive 4, because when you multiply negative 9 times a positive 4, you get negative 36, but when you add them together, you get a negative 5. Alright, so again, the zero product theorem, either one of these numbers or both of them is 0. Either x minus 9 equals 0, or x plus 4 equals 0. Well, these are just one-step equations, very easy to solve. The inverse operation of subtraction is addition, so you add 9 to both sides. And the inverse of addition is subtraction, so you subtract 4 from both sides. When you have an equation of degree 3, you're going to have at most 3 solutions. Now, sometimes they might be repeated values, but we're never going to have 4 solutions. So we know we're done with this problem. We've got 0, and if you can see that if you plug in 0, you just have 0 minus 0 minus 0, and it checks. That's 0. And if you took some time to plug in into a calculator 9 cubed minus 5 times 9 squared minus 36 times 9, you would see that that arithmetic is also 0. And if you plug in a negative 4, remember to put parentheses around the base, around the negative 4, because the negative 4 squared is 16, but then that negative 5 times 16 would be minus 80. So you have to be careful when you're using your calculator when you have negative bases. But for number 7, these are the 3 values that I get that are solutions to this equation. And they're all real numbers. It wanted real solutions. Let's take a look now. This is our familiar quadratic equation. We may spend some time trying to factor this, and we might be able to see, hey, I don't think you can factor this, so even if you could, let's use the quadratic formula just for practice, because we know the quadratic formula will always work. So let's identify, this is set equal to 0, so let's identify a, b, and c. A is equal to 5, b is equal to negative 14, and c is equal to 2. Now I know that the quadratic formula, remember that we talked about it at the beginning of the video. Here's my quadratic formula, but I also know the discriminant b squared minus 4ac will provide me some information. So rather than just jump in and do this quadratic formula, I'm going to review and I'm going to find this discriminant first. So the part that's underneath the radical, eventually I'm going to have to figure out what it is anyway. This b squared minus 4ac is called the discriminant. B squared, if we take negative 14 times a negative 14, I think that we get 196. I hope I'll check that in just a second on a calculator. Sometimes my arithmetic skills are not what they should be. Minus 4 times 5 times 2. Okay, so we have 196 minus 4 times 5 is 20. and 20 times 2 is 40, and if I subtract that I get 156. Alright, now actually I'm going to grab a calculator and double check. Hey, I better pause this because I don't know where my calculator is. Alright, so I think I'm back. I found my calculator and I checked that the 156 is correct. 156 is not a perfect square. So I believe that my final answer are going to be two irrational solutions. That I am going to have a radical in my final answer. Two irrational solutions. So let's look back. When I was talking about these different cases, the discriminant I found was 156, and 156 is bigger than 0, not less than 0, so I didn't have imaginary numbers as an answer. 156 is not equal to 0, so I had more than one solution. Because my equation had a degree of 2, I'm going to have at most 2 solutions. That means that in these final two cases, 156 was positive, but 156 is not a perfect square. 156, here it is. In this case, it's two irrational solutions. So that's what we're going to see for our final answer. So let's go and calculate that final answer. Alright, let's come back to our quadratic formula. The opposite of b, the opposite of negative 14 is positive 14, plus or minus the square root of the discriminant. Well, the b squared minus 4ac, we already found that to be 156. And divided by 2 times a is 5, so we have a 10 in our denominator. Now, let's take a look. Whoop, wait a minute. Oh, it is so strange talking this out loud to an empty room, and then to hear things and think that people are knocking on the door or something, and it was nobody. But all right. They're going to think, why is he in there talking about, he loves math so much, he's just out there talking out loud. Alright. 156 is divisible by 4. 156, I think, is 4 times 39. So although 156 isn't a perfect square, I can find a perfect square that divides it. So, and I know the square root of 4 is 2. Now, I can't simplify 39 other than to recognize that it's 3 times 13, and neither one of those are perfect squares. So here's the prime factorization. Nope, it's not a prime factorization because 4 it can be factored to 2 times 2. But anyway, this is divided by 2 times 5, which is 10. But I notice that 14 and 2 are each divisible by 2. See, I can't come in and cancel an individual term, but both of these terms are getting divided by this value. So when I take 14 and divide it by 2, I get 7. When I take 2 divided by 2, I get 1. So here's my final answer for this problem number 8. And you can leave it like that. Remember, the final exam is going to be multiple choice. I think I just heard people clap and yell hooray. Just kidding. So look for one of these choices. And again, it's going to be in reduced form. You're not going to see it as 14 plus or minus 2 radical 39 over 10. You're going to have to reduce fractions and simplify radicals to find that answer. Alright, so let's take a look. We have another quadratic equation. But it's not in standard form. It's not equal to 0. So you have to be careful. You need to get this guy, add 7 to both sides. You need this to be 0. Well, once again, I can't factor this, So I'm going to have to use the quadratic formula. A is equal to 1, B is equal to 4, C is equal to 7. The discriminant is the part that's underneath that radical. And based on its value, we have a little bit of idea of what type of answers that we expect for this quadratic equation. B squared is 4 times 4, which is 16, minus 4 times 1 times 7. Well, 4 times 7 is 28, and 16 minus 28 is a negative number, so negative 12. So I'm expecting to imaginary solutions, two complex solutions. Alright, so let's see if we can find them and determine what they are. So the quadratic formula says that it's a fraction. The numerator, it begins with the opposite of b. The opposite of 4 is negative 4. Plus or minus the square root of my discriminant. And I know that, let's come over here and think about what this discriminant, the square root of negative 12 is. Well, because that negative sign, I know that the square root of negative 1 is I. And so I need to think about the square root of 12. Well, I can write the square root of 12 as the square root of 4 times the square root of 3. The square root of 4 I know is 2. So I times 2, or I'm going to write it as 2I times the square root of 3. So there's my numerator. My denominator, 2 times a, well, a was just 1. Well, that's the number 2. And again, this denominator divides both terms, not just our favorite term. So, think about it as splitting up the fraction. This is a single fraction, and you can split it up as negative 4 divided by 2 plus or minus 2I times the square root of 3 over 2. See how you have a common denominator there, and you could just add these numerators together and you get back what you started with. That's why each of these terms gets divided by 2. So we've got negative 2 here, plus or minus 2 divided by 2 is 1. I like to put the I in front of the radical so that nobody thinks I'm taking the square root of 3i, which would be incredibly challenging for us to do. It's difficult to take the square root of I, not without knowing trigonometry and some other tricks and stuff. So like I say, it's beyond the scope of this course. So there's our two solutions, one with addition and one with subtraction. And they were complex numbers, they were imaginary numbers like we expected. We knew when that discriminant was negative that we were going to have I in our final answer. Alright, so here's one that's specifically saying, hey, calculate the discriminant and determine describe the nature of the roots of the solution. So this guy's in standard form, it's equal to 0. So a is equal to 3. B is equal to 19, and C is equal to negative 8. When you guys did this before, one of the biggest mistakes was to include the radical to take the square root of this. You don't take the square root. It's the number that's underneath the square root. It's b squared minus 4ac. So we're going to square 19 minus 4 times 3 times negative 8. So I know this is going to be a positive number because this negative and that negative, this guy's all going to be a positive number. Now I need a calculator because 19 squared, 361. Okay, I guess I could have guessed that. And we're going to add, get 457 if I have done that correctly. Now, I don't believe that 457 is a perfect square. Let's take the square root of it on the calculator and see if we get a decimal number. I do get a decimal number, so I know that's not a perfect square. So I'm expecting two solutions because this guy was not 0, and because it's positive, I'm expecting real numbers, not imaginary, and because this is not a perfect square, I'm expecting irrational numbers as solutions. So it's positive, two solutions, two real solutions, and real number, because it's not a perfect square, real numbers can be categorized as either rational or irrational, but not both. So two irrational solutions. And we don't have to go any further with this one. They don't care what the solutions are. They wanted us just to describe them, to determine the nature of the roots of the solutions. So two irrational numbers as solutions. All right, so here we have an equation, a radical equation. The radical is by itself. That's always what we have to do, is get that radical by itself. And the technique is to square both sides of the equation to get rid of the radical. So on the left-hand side, the radical goes away and we have x plus 3. On the right-hand side, this means x plus 1 times x plus 1. The exponent does not distribute. So if you have to come over on the side and construct a little table of scratch work, don't be afraid to do that. I have plenty of scratch paper if you need it for the final exam. One times 1 is 1. Be careful. The number of times that I have written 2 there is embarrassing. So this guy is x squared plus 2x plus 1. This is a quadratic equation, but it's not in standard form. I need this left-hand side, I need one of the sides to be 0. So I'm going to subtract x. When I take x away from the left-hand side, that goes away. And when I take an x away here, rather than 2x as y, I'll just have 1x. When I take away 3 from both sides, one minus 3 is a negative 2. Now, again, if you don't see a way to factor that, you can solve this with the quadratic formula. But I believe that we can factor it. Our middle term is positive, so we're going to have one positive value and one negative value in our factor. And the bigger one in magnitude has to be positive. So between 2 and 1, I chose 2 to be positive because 2 minus 1 is 1. And positive 2 times a negative 1 is negative 2. That gave me possible answers of negative 2, because negative 2 plus 2 is 0, and 1. And I said possible answers because remember, these could be extraneous. Maybe both of them don't check and we have no solution. So we're going to have to come up and plug these in and check. If you're confident that you haven't made an arithmetic mistake, to determine whether these are extraneous or not is simply to see if you've taken the square root of a negative number. If we plug in negative 2, 3 minus 2 is 1, and hey, I know it's not extraneous, but let's go ahead and actually check and make sure that we haven't made a silly mistake. So if we're going to check x equals negative 2, on the left-hand side, everywhere we see x, we replace it with negative 2. So we've got negative 2 plus 3. And the question is that equal to, if we plug in negative 2 on the right-hand side, negative 2 plus 1. So apparently I lied. 3 minus 2 on this side is 1, but over here it's negative 1. And we know that 1 is not equal to negative 1. So I've made a mistake in the sense that sometimes when you plug in an extraneous solution, may not be taking the square root of a negative number. It may also include the false claim that the square root of a number is negative. See, this radical means the positive square root. You'll never have the square root of 1 equaling negative 1. Alright, so this guy is an extraneous solution. It satisfies our equation above, but it doesn't satisfy our original equation. Let's check x equals 1. On the left-hand side, if we plug in 1, what do we have? Well, we have 1 plus 3, which is 4, and the square root of 4 is 2. Now the question is that equal to, on the right-hand side when we plug in 1, we've got 1 plus 1, and hey, that's 2. 2 equals 2. It does check, and this guy is our solution. So you can have extraneous solutions that do not result in the square root of a negative number, but result in the false claim that a square root is equal to a negative value. Again, we have another radical equation. Now this one is going to be longer than the previous one because we have two radicals. We have to have at least one radical by itself to start, and on the left-hand side that radical is by itself. So we're going to square the left-hand side and we're going to square the right-hand side. On the left-hand side, the radical is just going to go away. We need to take some extra care when we're squaring this. 5 minus the square root of x times 5 minus the square root of x. I suggest that you do that using a table. Alright. For the entries of my table, let's change color here. 5 times 5 is 25. And here when I multiply these, I just have a negative, and I'll just write it as negative 5 radical x. And here again, negative 5 radical x. Now, in this one, a negative times negative is positive, and the square root of x times the square root of x, hey, the radical goes away because it's the square root of x squared. Alright, so now we have enough information in our table to come back to our original problem. On the left-hand side, when we square that radical, the radical goes away and we just have x plus 4. On the right-hand side, when we add up the entries in this table, we have an x there. We're adding 25. And these two, this diagonal, those are like terms. We have negative 5 of these things and another negative 5 of those things for negative 10 radical x. So we have to get this radical, this term by itself. If we subtract x from both sides, we see that the equation is simplified quite a bit, that this term goes away and so does that term. So let's just go ahead and cancel those out now. If you subtract x, both of those cancel. So let's subtract 25 from each side. And here I have a negative 21. Here those guys cancel, and don't forget that minus sign that's in front of our 10 right there. Alright, now with both sides being negative, I can multiply each side by a negative 1 and those become positive if you'd like. Now to get rid of this radical, I'm going to square both sides of this equation. 21 squared. 21 squared is 441. Now, remember this is 10 radical x times another 10. 10 times 10 is 100, and the radical goes away. So to get x by itself, we divide, getting tired. We divide by 100. To divide by 100, we can just move that decimal point over for each power of 10. So I know that that's 4.41. Let's plug it in and check and see if it checks. On the left-hand side, 4.41 plus 4 is an 8.41, and the question is that equal to 5 minus the square root of 4.41? So let's go to the calculator. On the left-hand side, the square root of 8.41, I get 2.9. Now on the right-hand side, 5 minus the square root of 4.41, I get 2.9. So this does check, and that is my final answer. So I hope that helps. Here we have a rational equation. So our technique for rational equations is to get the same denominator everywhere. Well, we're pretty lucky that this denominator is x plus 2 and this denominator is x plus 2. But for this 5, I'm going to write it as 5 over 1. I need to multiply this 5 by the number 1. But I'm going to be clever in how I write the number 1 and write it as x plus 2 over x plus 2. So what does that get me? It gets me the denominator. When I multiply fractions, it's real easy. You just multiply straight across the numerator and denominator. I have 2 over x plus 2 I have, if I distribute that 5, I've got 5x plus 10, and 1 times x plus 2 is just x plus 2, and here x plus 2. So all these, if I multiply both sides by x plus 2, those denominators all cancel, and the result is an equation with no fraction. So again, I hear cheers. Most students apparently don't like fractions very well, so they see that when we simplify this equation that has fractions to an equation that doesn't have fractions, they're pretty happy. Alright, 2 plus 10 is 12. Let's subtract x from both sides. 4x plus 12 is equal to 0. So that means that 4x has to be equal to negative 12, which means that x has to equal negative 3. Alright, so let's check this negative 3. On the left-hand side of our original equation, we've got 2 over negative 3 plus 2 plus a 5. And the question is that equal to a negative 3 over negative 3 plus 2? Everywhere we saw x, we replaced it with negative 3. So on the left-hand side here, this negative 3 plus 2 is just a negative 1. And 2 divided by negative 1 is a negative 2. And 5 minus 2 is 3. Now on the right-hand side, we've got negative 3 in the numerator, and negative 3 plus 2 is negative 1 in the denominator. Negative divided by negative is 3. And hey, 3 equals 3, so this checks. Alright. Here we have a system of linear equations. Our technique here is to use a process of elimination, not substitution. Alright, so if I were you, I would scan and I would look for coefficients that are equal and opposite. So if we label these equations 1, 2, and 3, I see that I have a negative 2z and a positive 2z, and also with that 1z, I'm going to eliminate z's as my first step. So I'm going to use equations 2 and 3 to do it. I'm going to take equation 2 and I'm going to add to it equation 3. So let's see what that resulting equation is. We'll call that resulting equation 4. So if I take equation 2, which is 2x plus 3y minus 2z equal to negative 10, and equation 3, put a 1 there just to help us, 1x. Sometimes it's nice as a visual aid to put a coefficient of 1. When I add these two equations together, I get a new resulting equation that's 3x plus 7y. My z's were eliminated exactly like I wanted. Okay, and these add together to negative 5. So this is my equation 4. Now notice my equation 4, it's simpler than equations 1, 2, and 3 because it only has 2 variables. These have 3 variables. Well, now I need to eliminate z again. And this time I have to use equation 1. Now I can do it in combination with equation 2 or equation 3. So I'm going to use equation 2. You see how this says negative 2? I need this to be a positive 2 for those z's to cancel. So I'm going to take 2 times equation 1, and then I'm going to add equation 2. So in equation 1, if I multiply both sides by 2, I get 2x minus 4y plus 2z is equal to 24. Equation 2 is 2x plus 3y minus 2z is equal to negative 10. I add these together and I get 4x minus 1y. The z's are eliminated just like we wanted, and 24 minus 10 is 14. Let's call this equation 5. So now instead of having 3 equations and 3 unknowns, we have 2 equations and 2 unknowns. The number of unknowns must equal the number of equations for us to have a unique solution. Alright. So we need to make a decision to eliminate the x or to eliminate the y. Since we have here a -1 and here a +7, I'm going to choose to eliminate y. I'm going to eliminate the variable y. And I'm going to use equation 4. And I'm going to add to it 7 times equation 5. Now this is just my scratch work to help me keep things straight. So this equation 4 is 3x plus 7y is equal to -5. Here everybody gets multiplied by 7. So I've got 28x minus 7y, and 7 times 14 might be 98. Let's see. Yeah. Alright, so if we add these together, we've eliminated y. And we have 31x is equal to 93. Well, let's take 93, divide it by 31, and we get 3. That's awfully nice. Now, don't stop there. We need answers for x, y, and z. We've just found an answer for x. So let's come back to either equation 4 or 5, replace the x with 3, and solve for y. So I'm going to pick equation 5. I'm going to write equation 5 again, but instead of writing x, I'm going to write 3. So I've got 4 times 3 minus y is equal to 14. 4 times 3 is 12. And 12 minus a -2 is the same thing as 12 plus 2. In other words, I know that y is going to be -2. If you subtract 12 and then multiply by -1, you'll see the same thing. Alright, now we have x and y, and we need z. So we have to come back to one of the original equations, because that's the only ones that had x, y, and z. I can pick any of the ones I want for z. Since this has a coefficient of 1, I'm going to pick equation 1. So, let's do it over here. We knew that x was 3. We determined that y was -2. And z we don't know, we're trying to figure out. So, that negative times negative is positive, and 3 plus 4 is 7. And if we subtract 7 from each side, we get that z is equal to 5. So our final answer of x, y, z, and it's common to write it in the order x, y, z as a triple, ordered triple, not a pair. There's 3 of them. X is 3, y is -2, and z is 5. So there's our final answer. If you plug those into either one, any of these equations and stuff, every equation will be satisfied. You have lines in 3-dimensional space, and you're trying to find, that's the point of intersection where these 3 lines in 3-dimensional space all intersect each other. Alright, so we have an application. Now don't be afraid that it's a word problem, because really we're going to ignore most of the words. Who cares if it's Bob, or I know it's Bob because it's Robert Morris, right? Alright, we've got a 120-foot cliff, and again, I don't care about that. I have an arrow, and it's being shot above the ground. Okay, it can be modeled as this function. Here's what I'm interested in, is this equation. Now this equation is a quadratic equation, because I can see the exponent 2. With a negative in front of that t squared, if I go to graph that, I know it would be a parabola that opens downward. Okay, so if this is the ground, what's going on is that we're shooting an arrow, and it's going up in the air, reaching a maximum height, and then turning around and coming down and hitting the ground. So it says, when will the arrow be 184 feet? The height, the h is the height. The input into this function is the length of time after you've shot the arrow. So you're standing over here on the ground, or actually on the top of a cliff. That, I guess, really doesn't matter that much, but you're standing on the top of a cliff. You shoot your arrow up in the air, it comes up and reaches a maximum height, and then it comes all the way down and hits on the ground below the cliff. Alright, so as time passes, our arrow the height is changing above the ground. So when will it be 180 feet above the ground? Well, if this is 184 feet, it's going to cross that on the way up, but then it's also going to cross it. It's going to be 184 feet on the way down, unless 184 feet is the vertex, is the maximum of that parabola. So this is 184 feet as well. So the 184 is the output of our function. So the picture was just simply to try to understand the problem a little bit better. And basically what we determined is what goes up must come down. The left-hand side is the height, the 184. The right-hand side, negative 16t squared plus 96t plus 120. We need to solve this quadratic equation. So we know that we want to write it in standard form. We want this to be 0, and we know that we're going to have at most 2 solutions. So let's subtract 184 from each side. We get negative 16t squared plus 96t, and 120 minus 184 is a negative number, and that's negative 64. Now I think all these numbers are divisible by 16. In fact, I'm going to divide all of them by a negative 16. So I'll divide the 0 by negative 16. Well, hey, that's going to give me 0. Divide this by negative 16. Divide this by negative 16. Everybody gets divided by negative 16. So on the left-hand side, I have 0. Here, the negative divided by negative is just 1, so I have t squared. 96 divided by a negative 16 is a minus 6t. And a negative 64 divided by a negative 16 is 4. Okay, so it doesn't appear to me that I can factor that. I'm going to have to use the quadratic formula. Alright. So let's identify A, B, and C. A is 1, B is negative 6, C is 4. We're going to have the opposite of B, which is the opposite of negative 6 is positive 6. B squared minus 4AC. Well, B squared negative 6 times a negative 6 is 36 minus 4 times A times C, all divided by 2 times A. Boy, a nice feature about writing on this wireless tablet is that I can shrink these values, shrink my size up, and create plenty of room to work in. Alright, so 36 minus 16 is 20. So I've got 6 plus or minus the square root of 20. But the square root of 20, 4 times 5 is 20. So I've got 6 plus or minus 2 radical 5 divided by 2. Half of 6 is 3. Half of 2 is 1. So what is the square root of 5? Well, that's 2. So I'm getting 2. See, well, I knew it was smaller than 3. If we won't have a negative time, we would throw that answer out if it were negative. So I believe if I go to a calculator and get decimal approximations, if I take 3 minus the square root of 5, I get 0.76 to 2 decimals. So very quickly after you shoot it, less than a second after you shoot it, you're already on 120 feet above the ground. So it's the arrow is going really fast, and it's up at 184 feet pretty quick. Then it's going to come up and reach its maximum height. I don't know what that is, but on the way down, let's say 3 plus the square root of 5. In 5.24 seconds later, So a little bit after 5 seconds after you shot the arrow, it's reached its maximum height, that's past that, and it's on its way down again, and it's 184 feet above the ground. Alright, so those are our two answers. When, after you shot the arrow, was the arrow 184 feet above the ground? Quadratic equation, two solutions. Now, most of the time those are set up that we can factor it, but hey, this time the quadratic formula, we got decimal numbers and stuff for our answer, and that's fine. So here is our mixture problems. We have a radiator. I like to draw pictures to help me understand the problem. This radiator is a fixed volume container. It holds 6 quarts. Now, the current mixture is 50% antifreeze. How much fluid must be drained? We're going to drain some of this out, and then we're going to replace it with water. So, when we drain it out, I don't know how much we're going to take away, but we're going to take away some of this fluid. When you take away that fluid, we don't know how much, so it's X quarts. Opening up the drain and draining it out isn't changing the concentration. But when we go to refill that radiator and we add pure water, water doesn't have any antifreeze. Whatever we drain out, we're going to refill, and then that's going to dilute it. That 50% is going to go down to, it says 35%. And when we refill it, we're back up to 6 quarts. Alright, so now I can create an equation. I've got 6 times 0.5 because I'm going to change that to a decimal. I've got 0.5 times x. I've got 0 times x, which is just 0. And I've got 0.35 times 6. One equation, one unknown. We can solve this for x. So, if I take 0.35 times 6 and I subtract 6 times 0.5, I get that this negative 0.5x is equal to a negative 0.9, so I divide both sides by a negative 0.5, and I get 1.8 quarts. So, if you're wanting to dilute your antifreeze, currently in your radiator it's 50%, you want 35%. If you drain a little bit less than 2 quarts, 1.8 quarts out of your radiator, fill it back up with water. When you fill it with water, it's going to dilute it, and 1.8 quarts of water is going to make that concentration 35% antifreeze. Alright, so let's take a look. Again, we have another mixture problem. How many ounces of pure vinegar must be added to 12 ounces of salad dressing with a 10% vinegar solution to form a new salad dressing with 25%? So we've got this salad dressing, and currently it's 10%. So somebody's thinking, hey, I want it stronger, 10% vinegar, and you've got 12 ounces of this. You're going to add to that vinegar. Well, vinegar is 100%. Pure vinegar is all vinegar. We don't know. We're trying to figure out how many ounces of pure vinegar, so that's going to be our variable x. When you add to this, you're going to have more than 12 ounces now. You're going to have the 12 ounces of your original solution plus the number of ounces of your vinegar. What that's going to do is increase that 10% to a stronger salad dressing. Alright, so now the picture, at least it helps me understand the problem a little bit better, and hopefully that's the intent for you guys as well. But now we want to transition into an equation. The percent, I change it to a decimal. 100% as a decimal is just 1. I do need the parentheses because everybody inside here gets multiplied by the 0.25. So, see what we have here. We have 1.2 plus x is equal to 3 plus 0.25x. Let's subtract 0.25x from both sides because here's a 1. So we have 1.2 plus 0.75 is equal to 3. Let's subtract 1.2 from each side. And 1.8. Alright, so take 1.8 and divide it by 0.75, and I get 2.4. And that's in ounces, and that's our pure vinegar. So, if you have this 12 ounces of salad dressing, you want to make sure that it's in a container that's bigger than 12 ounces because you're going to add 2.4 ounces of pure vinegar, shake it up, and you get a new solution that's 25% vinegar. Hey, I hope that helps for skill 2 and that this wasn't too long. Sometimes when these videos are long, they don't always record. So I hope that you'll hear this. Talk to you later.